do? If I asked you to take out the greatest common factor here, what would you do? Two x to the power of 3? What's inside the brackets? All right. That's the right answer, right? Okay. How did you get that answer? So what you factor out, I just want you to really think about what you're doing here. Whatever you factor out, you actually divide each term by that factor. You were probably told this a long time ago, but then forgot it. So that's what you get with, that's how you get what's left inside here, right? 4 divided by 2 is 2, x to the 5th over x cubed. You subtract the exponents, you get x squared. That's 1, that's 3x to the 7th. That's how you do it, okay? It's the same thing with fractional exponents. So if we have, we'll start simple. Okay, before we do this one, x to the power of a half minus x to the power of 5 halves. Which exponent did you take out? Sorry? You take out the smallest. You do that even with fractional exponents. So, which is the smaller exponent? 1/2 or 5 halves? So that's what comes out. And then you divide everything by what you took out. So you obviously don't have to show this, but just for educational purposes, we will. What's x to the 1/2 divided by x to the 1/2? So I'm left with 1 minus x to the 5 halves over x to the 1/2. What do you do with the exponents? What's 5 over 2 minus 1 over 2? 4 over 2, which is? That's it. All right. Does that make sense? It's the same principles you've always been using. Okay, there's a lot of stuff going on here. All right. Do we see two sort of things that we want to pull out? What are they? What variables or terms can we? Yeah, there's an x and an x plus 3. So look at the x's first. We have a choice between x to the negative 1/2, x to the positive 1/2. You always take out the smaller exponent. So what am I taking out? Okay. Now you have x plus 3 to the power of a half, x plus 3 to the power of negative a half. What are you pulling out? What are you factoring out, I guess I should say? Negative a half, right? Okay. You divide by those two. So I'm just going to show it. X to the negative 1/2, x plus 3 to the negative 1/2. Again, you don't have to show this step, but I think it helps when we're first going over it. In the first expression, what happens to the x to the negative 1/2? They go away, they cancel, right? They're 1, essentially, because they're the exact same. What about the next one, or the next bit? X plus 3 to the power of a half divided by x plus 3 to the power of negative a half. What do you do with the exponents when you're dividing? You subtract. So really what you're doing is you're going 1 half minus negative a half, which means you're adding them. What's a half plus a half? 1. So you're left with x plus 3. I'll write it. Obviously, you don't need to write it. To the power of 1. Second term, x to the 1 half divided by x to the negative 1 half. That's just x, right? Because it's the same idea. 1 half minus negative a half is 1, so it's just x. What happens to the x plus 3 things? To the negative 1 half? What happens to them? They're gone, right? They're just 1. So I'm just left with that in the brackets. You can simplify that. Collect your like terms. So what do you get? X plus x is? And there's your answer. Is that okay? All right. Let's try a trickier one. You want to try it on your own? Do you want me to do it with you? Okay, what is the lowest exponent? Negative 3 over 2, right? So that's what comes out. Are there any common coefficients that I can pull out as well? 2. So I'm pulling out 2 x plus 1 to the negative 3 over 2. Maybe I should have written it off to the side. Okay. Then you divide by that which you took out. So 4 divided by 2 is 2. Negative 1 half minus negative 3 halves. Flip the signs. Two over 2, which is just 1. Plus the middle term, everything disappears, right? So it's just a 1. Final term, 4. 1 half minus negative 3 halves. Flip the signs. 1 half plus 3 halves is 4 over 2, which is 2. we done? You can clean all that up. So you can dump the 2 in. Plus 1. X plus 1 squared, I have to expand. With the 4 on the outside. And then it's just algebra after that. Expanding, collecting like terms. Don't worry about factoring if it is even possible. The 4x squared plus 10x plus 4, or plus 7. Sometimes they'll want no negative exponents, so you would drop that down to the denominator. So you could write it like this. Like that. You can put the 2 in if you wanted. What's 3 halves as a radical? Yeah. Sometimes you want to write it like this. It really depends on what the question is asking. But this is all sort of shows up when we do chain rule stuff, which is chapter 2. You can write it like that too. Those are all the same thing. Again, dump the 2 and whatever. I mean, there's an infinite number of ways you could write it. But this sort of stuff, taking like this would be built into one question. There'd be a bunch of other stuff, and then all this simplification to get to this. All right. So the calculus is done way up here, and then it's algebra to get to here. All right. A lot of this class is going to be algebra. All right. These type of skills. Okay. Give you one to practice, and then we'll move on to some other stuff. Factor and simplify. That, please. Simplify as far as you can. No negative exponents. Really?
I did this one. I did that one better, right? And so it's like,
So you're like, I did the first one on the paper, so obviously it doesn't increase in complexity. It's not
the kinetics test though, I didn't do that. Once it got to equilibrium.
I just want, no, I just want this. I just want to know what's all Big up.
So bad. I don't even know why.
Wait a second.
It, I know. It's just like, Stop. Sorry.
That's not really cool.
Reaction to it. Oh.
It's well, maybe she'll just talk about it because a lot of it's the actual math. You guys use it.
Which kind of sucks?
This is all review though. Graphic rational function.
Not that my dad
Thank you. I will give them back. All right, we ready? What's the answer? What? An answer? Is it that? X is 6 plus 4x cubed plus 5 over x cubed plus 2 to the 5/3? Yeah? Did we get it? All right, peoples. Oh, I left the recording that whole time. That's weird.